All right, we're going to talk about operations with polynomials. So operations, your addition, subtraction, multiplication, division. Polynomials is just another word for expressions. More specifically, your expressions have to have exponents that are positive and whole numbers. You might not have any exponents, but if you do, they have to be positive and whole numbers. These are your general expressions you're going to think of, so nothing too out of the ordinary. We are going to focus first on addition, subtraction, and multiplication. You've seen these before. I know you have, because when you dealt with your complex numbers, you added, subtracted, and multiplied complex numbers, and polynomials is going to be very, very similar. I also know that you saw this back in Algebra 1. We're going to save division separately in a separate lesson because you have most likely not seen how to divide polynomials. It's not the same as how we divided our complex numbers in Unit 3. So we also need to recall a function has a notation of f of x or g of x or h of t, something like that, where you have your function name on the outside and x or whatever's on the inside of your parentheses is your input to that function. So we can take any two or more functions, add, subtract, and or multiply them using your function notation. So this is a function, this 2x plus 3 is the polynomial part, and this x minus 4 is the polynomial part. So like I said, you've seen those before. That's polynomial. Our notation here says we're going to take these two functions, f and g, and multiply them. So that first part, now you don't have to write this, I'm just showing you that the notation f times g of x is the same as saying f of x times g of x. Similar in the second one, that's the same as saying f of x plus g of x. Ran out of book. Now, what is super important with addition, subtraction, and multiplication and any of those combined? When you take each of your functions, you need to initially start with the function in parentheses and your math in between. So what I mean by that is I'm going to take function f, 2x plus 3. I'm going to keep that in a set of parentheses first. Times, because that's what it says, times. Now I'm going to take g of x, 4x minus 7, in a set of parentheses. After you have it set up, you do the math that you need to. Multiplication, like this one, is where you do your FOIL method. You only do FOIL with multiplication. 2x times 4x is 8x squared. 2x times negative 7 is negative 14x. 3 times 4x is a positive 12x. And 3 times negative 7 is negative 21. I have these like terms here, so my final answer is going to be 8x squared. Negative 14 plus 2 is plus 12 is minus 2x. Minus 21. So if you're just multiplying two functions together, make sure you use your FOIL method. In your next example, we're going to take the same functions, except this time it says we're going to add. So we're going to take 2x plus 3 plus 4x minus 7. With addition and subtraction, you do not do the FOIL method. Addition, you look in front of both of those parentheses, there's imaginary ones here. So I could distribute that one and it's not going to change anything. Same thing here, I'm going to distribute that and it's not going to change anything. So with addition of two polynomials, you essentially just drop your parentheses and you now combine like terms. 2x plus 4x is 6x. 3 minus 7 is minus 4. So multiplication, you FOIL. Addition, just combine like terms. So now let's look at subtraction. So the first one says I want to take h of t and subtract p of t. So I'm going to take h of t, which is 4t squared plus 3t minus 8. Minus p of t, which is 3t squared plus 4. Once again, with subtraction, we do not do FOIL, but the subtraction is important because the subtraction here needs to distribute to both of the terms in that set of parentheses. So your first set of parentheses is not going to change because there's a positive 1 in front, which doesn't change anything. But your second set, you need to distribute that negative to both of those terms. Then you can combine your like terms. 4t squared minus 3t squared would be 1t squared, or just t squared. You have a 3t with no like terms. And then you have a minus 8 minus 4, which is minus 12. Now, the next one has the same two functions being subtracted. So, is my answer just going to be the same? Well, hopefully you said no, because I switched the order. Now I want to take p and subtract h. Subtraction, the order matters, right? 4 minus 3 is not the same as 3 minus 4. So with addition and multiplication, if I would have switched the orders around, if I would have asked you to do g times f, you'd get the same answer. If I would have asked you to do g plus f, you would get the same answer. But here, when I switch the order around for subtraction, it's going to change the answer. So I'm going to take p and subtract h. Once again, that first set of parentheses has a positive 1 in front. It's not going to change anything. But the second set, I'm going to distribute the negative to all the terms. To get minus 4t squared minus 3t plus 8. And then combine like terms. 3t squared minus 4t squared is negative t squared, or negative 1t squared. I have a minus 3t with no like terms. And then I have a plus 4 and a plus 8, which is a plus 12. And something you should start getting in the habit of doing is writing your answers in order from largest to smallest exponent. So I wrote this one as this t squared and then the t and then the constant. I don't want your t squared, your constant, and then t. Okay, I want you to get in the habit, because you're going to pretty soon have to do it that way, writing it from largest to smallest exponent. Now, we also can do one like this. Let's talk about what this means. So 4f plus g squared. So that means I want 4f of n plus g of n squared. This is 4 times f of n. So I'm going to take 4 times f of n plus g squared. Now the first one we can just distribute. This 4 to both of those terms would give you 8n squared minus 12n plus. Now recall that this, because of this squared, means to write that parenthesis twice. And FOIL. 5n times 5n is 25n squared. 5n times negative 4 is negative 20n. Negative 4 times 5n is negative 20n. And negative 4 times negative 4 is a positive 16. Once you look something like this, you can just combine like terms. I have an 8n squared plus 25n squared is 33n squared. I have a negative 12n minus 20n minus 20n is a negative 52n. And I have a plus 16 with no like terms. So super important, just remember that when you are squaring your function, you have that function twice and you need to do your FOIL. It's not 5n squared and then 4 squared. That's not how that works. All right, and then the last part we're going to talk about is how you can also evaluate functions once you have addition, subtraction, or multiplication, similar to how we would evaluate a normal function, but you're going to do your simplification first. You would do whatever you need to simplify this, and then you can evaluate. So first, let's just recall how to evaluate a function. So if I gave you the function f of x equals 3x plus 7, and I want you to use f of 2, the 2 is inside where the x is, so to find f of 2, you're going to just replace all of the x's with a 2. So 3 times 2 plus 7, which would be 13. So we're going to do the same thing, except first we need to simplify our function using our addition, subtraction, multiplication, whatever, and then evaluate. So on this first one, we're going to first simplify 2f plus h. So 2f plus h. So 2f, we're going to distribute that 2 to get 4x plus 14. The plus 4x minus 3, that plus doesn't change anything. You can just bring that down. Right, you're distributing a 1, doesn't change anything. We're adding, so we don't FOIL. Then you can combine like terms. 4 and 4 gives you 8x. 14 minus 3 is 11. Now use this and plug in 0. So 8 times 0 plus 11 is 11. That's your final answer. We're going to take f, 3n squared plus 4n minus 1, minus g, negative 3n plus 1, plus h squared, looks like an n. Your first one has a 1 in front, doesn't change anything. But the next one has a negative in front, which changes that to a positive 3n minus 1. And your squared part is 5n minus 3 times itself. 5n times 5n is plus 25n squared. 5n times negative 3 is minus 15n. Negative 3 times 5n is minus 15n. And negative 3 times negative 3 is a positive 9. Combining your like terms, we have 3n squared plus 25n squared is 28n squared. 4 plus 3 minus 15 minus 15 is negative 23n, and then negative 1 minus 1 plus 9 is plus 7. Then we want to find all of that plugging in a 1. So that's 28, 1 squared minus 23 times 1 plus 7. You can just type that whole thing in your calculator just as I have it written there. Super important here, put this 1 in parentheses with the squared on the outside like I have it. Typing that in your calculator, you get 12. That's the end. So make sure if you're simplifying, you simplify with the correct type of math. You only FOIL if you're multiplying, and that includes if you are squaring something, because that's multiplication. But if you're adding or subtracting, you do not FOIL. Addition, you just get rid of your parentheses, combine like terms. Subtraction, distribute a negative, and then combine like terms. If you are evaluating, you're going to want to simplify it first and then plug in your numbers for all of your variables.